Welcome back to our help videos on 3B7, arguably one of the most important units, 3B, for our understanding of everything that we do for the remainder of this year. So watch the videos, be sure you understand what is going on, and if the videos are not helping, please don't hesitate to ask questions. We're picking up with question 6, which deals with the following information. A neutral atom has 32 electrons. That says a lot right there. First, they're telling us it's neutral, and they're telling us there's 32 electrons, or 32 negative particles. If it's neutral, there must be 32 positive particles, or protons in the nucleus. So right out of the gate, they told us it's 32 electrons. We also must know that there's 32 protons, because for the atom to be neutral, the protons equal to the electrons. So if there's 32 electrons, then there's 32 protons. And we know from Moseley that the chemical behaviors and properties of an atom are related to protons. It's the number of protons which earns the atom placement as an element on the periodic table of elements. So we're looking for an atom or elements that have atoms with 32 protons. That would be germanium. We can look on the large periodic table. There's germanium. Any atom with 32 protons, regardless of how many neutrons, regardless of how many electrons it has, it is germanium. Germanium is 32 protons. Anything with 32 protons. Oh, question 6. The element belongs to what? Germanium. How many nucleons does the element have? We recall that nucleons are any particle in the nucleus. Up here, nucleons are particles in the nucleus. It's essentially, nucleons are the mass number. However, if we read this question right here, how many nucleons does it have? Well, if it has 42 neutrons, and those are particles in the nucleus, and it has 32 protons, those are particles in the nucleus, the number of nucleons would equal 32 plus 42. Nucleons are particles in the nucleus. It's essentially the mass number, protons plus neutrons. It has 32 protons, as we learned. They told us up here it has 42 neutrons. 32 and 42 is 74. That's letter D. That's letter D. Question 6 and 7. Now we move on to question 8. An isotope to the atom in this nuclear symbol below could reasonably have a mass number of what? What are isotopes? Isotopes are atoms of the same element. So for it to be an isotope to this element, it has to still be bromine, which means we can't change the atomic number. Any other number other than 35 here would no longer be bromine. Bromine is an atom, or bromine is an atom characterized by an atomic number of 35. Once again, on the periodic table of elements, that 35 can be in the upper right, lower left, underneath the element, above the element, right in the dead center. 35 is the atomic number, but anything with 35 protons in the nucleus is bromine. But bromine can have various numbers of neutrons. Neutrons are a neutral particle in the nucleus. So that number here can't change. Bromine must have a 35 there. But we can change this 80. Isotopes are atoms that have a 35, but not an 80. Isotopes have the same are elements of the same atoms of the same element that vary in numbers of neutrons. So we're looking for a number close to 80. We're looking for a different mass number close to 80. 36 is not really close to 80. 44 is not close to 80. 116 is not close to 80. 79 is close to 80. So if it has 79 protons and neutrons, again, if it has 79 protons and neutrons in the nucleus, there would be a 79 there. That atom, if it has 79 particles in the nucleus and 35 of them are protons, then that atom would have 44 neutrons. If there's an 80 here, and this is 35, that atom would have 45 neutrons. So what would make bromine 79 different than bromine 80? They would vary by 1 neutron. They would both have to have the same number here, 35, or it wouldn't be bromine. All right, we're moving on to some more questions. How many electrons would Se selenium 2- have? That would be the selenide ion. When it's negative, you put an "ide" on the end. How many electrons would the selenide ion S2- have? We have to have a periodic table to do this, because we can't figure out how many electrons selenium starts with. So I look on the periodic table of elements, and I'm down here. Selenium has a 34 in the upper left-hand corner, and it can be anywhere. That's telling us that selenium has 34 protons, but a neutral selenium would have 34 electrons. So if it starts with 34 protons, it would start with 34 electrons. As it becomes 2-, it would gain 2 electrons. 2- is negative, negative gain. They gain 2 electrons. 34 and 2 would be 36 electrons, letter C. 36 electrons. Does it make sense that the selenide ion would want to be 2- and get 36 electrons? You just need a periodic table to tell. Here's selenium. All seleniums have 34 protons. All seleniums start with 34 negative electrons to balance out the 34 positive protons. But selenium would love to get 2 more electrons and become the selenide ion, because 34 electrons would go up to 36. It would be stable like krypton. It has to gain 2 to have the same number as krypton. Krypton is in the noble gas family. They are stable. They are chemically stable. They have the number of electrons they need. If you look on your periodic table of ions, here's the selenide ion right there. There's the 2-. Here it kind of shows us even more detail. Selenium is in the 16th group over from the left, but we go all the way up to the top. It's in Roman 6 column. The ones in Roman 6 column, many of them want to become 2-. Why? Roman 6 means that selenium starts with 6 valence electrons. In its outermost level, selenium would have 6 electrons. 2 more into that outermost or valence level would give it 8. It would satisfy the octet rule. Krypton has 8 in its outermost level. Selenium starts with 6 in its outermost level. It needs 2 more to get 8. How many electrons does chromium 3+ have? Now, I wouldn't have to call it chromide or chromiumide, because the positive ones keep their name. The negative ones, we add the "ide" on. I don't know how we would go about doing this without a periodic table. Chromium 3+, we have to look on a periodic table. Chromium starts with 24 protons. Well, all chromiums have 24 protons, positive particles, so it starts with 24 negative particles to offset it. If it becomes 3+, it lost. Plus means it lost. You see the big positive sign in the word lost. It had to lose 3 negative things. In order to have 3 more positives than negatives, it has to lose 3 of the negatives, being left with 3 positives more than it started with. So if we line up, if chromium starts with 24 protons and 24 electrons, and we take away 3 of the negative things, we would have a remainder of 3 positive things. 24 minus 3, that would be 21 electrons. 21 electrons. If chromium becomes 3+, it says here chromium likes to become 3+. It doesn't really satisfy the octet rule, as we can tell directly. But it is possible for chromium to lose 3 electrons and become 3+. All right. Next set of questions. Here they've given us the fact that we have a neutral atom of gallium-70. Gallium-70 is hyphen notation. Hyphen notation. In hyphen notation, they either give you the symbol followed by the mass number, or they write the word out, hyphen mass number. They give us the mass number. Why don't they give us the atomic number? Because they told you it was gallium. If they told you it was gallium, you merely look on a periodic table of elements. There's gallium. It has 31 for its atomic number. So I can start writing a nuclear symbol format. I write gallium's atomic number in the lower left. That's where the atomic number goes. That's where the number of protons go in the nuclear symbol format. The number of protons can be anywhere in the square. The atomic number can be any of the square on the periodic table of elements. So where did I get that little gallium? I just found gallium right here. There it is, 31. 31 is its atomic number. So how many protons does gallium have? The atomic number tells you how many protons it has. It has 31 protons. For a neutral gallium, it said it's a neutral gallium. The positives must equal the negatives. So if it has 31 protons, it also has to have 31 electrons. So I'm looking for an answer with 31 as the first number and 31 as the last number. The only one that has 31 as the first number and the 31 as last number is letter E. But let's be sure that it should have 39 neutrons. They told us the mass number right here. In hyphen notation, they have to tell you the mass number because they're talking about a particular atom of gallium. On the periodic table of elements, they're not referring to a particular atom of gallium. They have 69.72. The average masses of the naturally occurring isotopes of gallium have 69, which means some galliums have 70 particles in the nucleus, some might have 69, some might have 68, some might have 72. But they all have 31 protons. So this is just the average masses of all the galliums, called the atomic mass. So the atom they're talking about has 70 particles in the nucleus. The mass number is 70. There's 70 protons and neutrons in the nucleus. But we know 31 of the particles in the nucleus are protons. So the rest are neutrons. 70 minus 31 is 39. Letter E is indeed correct. We're going to pick up with 12 through whatever is left on this page on the next video.